Hello guys, in this video I want to discuss variance for discrete random variables. And to motivate this conversation, let's first find the expected value of these random variables given these probability distributions. So remember, the expected value is computed as the summation over all x of x multiplied by the probability mass function. And this is essentially a weighted sum. So let's go ahead and do that. For the left, we have -2 for our x value multiplied by 2/5 plus 0 times 1/5 plus 2 times 2/5. This goes to 0, and these two terms cancel, and we get our expected value for this function to be 0. Doing the same procedure at the right, we see that -2 times 1/8 plus 0 plus 2 times 1/8 is equal to 0. So we have the expected value of these two distributions being very similar, well, exactly the same in fact. But these distributions are very different. So we introduce a new idea, variance. Variance is defined, the variance of x is equal to the expected value of x squared minus the quantity expected value of x squared. Since for both of these cases the expected value is equal to 0, we just need to compare the expected value of x squared for each. At the left, we have -2 squared times 2/5 plus 0 squared times 1/5 plus 2 squared times 2/5, which is equal to 4 times 2 over 5 plus 4 times 2 over 5. And this is equal to 16/5. And sometimes you'll see people write variance as sigma squared. And you might also know sigma is standard deviation. All right. And let's look at the expected value of x squared for the right distribution. We have -2 squared times 1/8 plus 0 plus 2 squared times 1/8. So we have 4/8 plus 4/8, which is equal to 1. So that's equal to sigma squared. So we can tell a lot from the variance here. The larger the variance, the more spread out the probabilities. Or how far away probabilities are from the standard deviation. On the left, we have a large variance of 16/5, which is more like 3.2. And then on the right, we have a variance of 1. So since the expected value of the right distribution is equal to 0, and a lot of the probability lies at 0, we can say that the variance is lower. Whereas at the right, some of the probability is concentrated further away from the expected value. So hopefully this gives you a little intuition behind variance for discrete random variables and why it's important to sometimes look into variance, as expected value doesn't always give you the full picture. Thanks for watching.